Method 2. Method 2 is called variation of parameters. Variation of parameters. Variation of parameters. Uh-oh, having some challenges spelling. Variation of parameters. Okay. All right. So, same problem. dx dt plus 3x is equal to t. All right. Variation of parameters technique. This first term has to be 1 there. It is, so there's no need to address that. Let's ignore that t temporarily and work with what we call a homogeneous equation. dx dt is equal to, we make that 0. And if we make that 0 and subtract the 3x over, we'd end up with that. All right. So then we can now separate the variables, use the separation of variables technique. We end up with 1 over x dx by dividing that over is equal to -3 dt. Take the antiderivative of both sides. We get natural log x plus c, we don't need to write it right now, is equal to -3t plus c. All right, let's solve for x. Solve for x. Make each of these sides the exponent of the e function. We end up with x sub t is equal to, you got to use a little algebra 2, e to the c times e to the -3t. Simplified, the e to the c, let's just call that k, e to the -3t. All right. So that's similar to what we've done in the other problem. And the thing that we said in the other problem is our solution is going to come about where we take x sub t and we're going to vary the parameters. So instead of this constant x, a lot of smart people have come to the conclusion and studied that you change that k, you vary the parameter, k sub t, e to the -3t. So just replace the k with k sub t. This particular time we're not going to go through the incredibly lengthy proof of why we can do that, but just trust me that this technique works. All right. All right. So this is our solution. All we need to do now is substitute into k sub t, and then we are done. Then we are done. All right. Now, what do we do now? Well, what we're going to do is verify that this is indeed the solution by substituting into this equation. To substitute this into this equation, you would need to take the derivative of this. All right, so let's go ahead and do that. You're going to need the product rule. All right, so x sub t is equal to the product rule. K prime sub t times e to the -3t, the derivative of the first times the second, plus the derivative of the second, which is -3e to the -3t. All right, that's the derivative of the second times the first, which is k sub t. All right, so that is the derivative of, I didn't write that. I didn't do a good job there. This is dx dt. Sorry about that. I just took the derivative of this using the product rule. So now what we're going to do is we're going to substitute that back into our original problem. So what we have here is, let's just rewrite this. We have k prime sub t e to the -3t minus 3e to the -3t times k sub t, that's dx dt, plus, now I'm going to substitute in x, which is right here, into our equation. So we have 3 times k sub t e to the negative 3t. That's x right there. And that is equal to t. Right? That's equal to t. All right? So now, what I'd like you to be able to see is we got negative 3 k sub t e to the negative 3t. And here we have positive 3 e to the negative 3t times k sub t. There's cancellation there. With this technique, there'll always be that cancellation. And if you don't experience that cancellation, you've made a mistake somewhere. All right, so fortunately, we haven't made a mistake. We end up with k prime sub t e to the negative 3t is equal to t. And now that is the same thing. That's the same thing as k prime sub t. Remember, we're trying to solve for k. Trying to solve for k and put it right there. Is equal to, you have to divide by e to the negative 3t on both sides. Hopefully I can convince you that that's going to be t e to the 3t. Because if that e to the negative 3t is at the bottom, moving it to the top would make that negative positive. So now what we have to do is, I told you we had to substitute into k sub t there. The only way we can do that is to solve for k here using the derivative of k. All right, so it's a lengthy process, I know, but with practice you can get very, very comfortable with this. So we get k prime sub t is equal to t e to the 3t power. You need to solve for k, you take the antiderivative. Again, you've got that product there. With experience, you know that you've got to use integration by parts. So u dv, antiderivative u dv, is equal to u times v minus the antiderivative of v du. That's what we're going to do right now. So u is t, du is 1 dt, dv is e to the 3t power. V, you'd have to take the antiderivative of this, is 1/3 e to the 3t power using u substitution. All right. So now what you're going to do is use this to take this antiderivative. All right. So antiderivative of k prime is just k sub t. And now let's substitute into this integration by parts relationship and end up with the antiderivative of this here. So maybe drop this down a little bit. Drop this down a little bit. So we end up with k sub t is, we end up with u times v. So we're multiplying these two terms. We get 1/3 t e to the 3t, that's u times v, minus the antiderivative of v du. So let's pull that 1/3 out, e to the 3t times du, which is dt. Right? So now we just got to take the antiderivative of this part right here. Then we'll be just about done. K sub t. This integration, this variation of parameters technique is, look how much longer this is than this technique. But we're just trying to share mastery level techniques. We want our children to be able to solve the same problem in more than one way. 1/3 t e to the 3t. You take the antiderivative of this. We've done this already. You end up with u substitution 3t, du, sorry about that, du is 3 dt. All right, so we got this 1/3 out there. We're taking the antiderivative of e to the u, where u is the 3t there, but if we put the du there, there's a 3 there that was not in the original problem. We multiply by 1/3, that would cancel the 3 out that was in the du. Let's rewrite this. We end up with 1/3 t e to the 3t power minus 1/9 antiderivative of e to the u is e to the u was 3t plus c. All right, so that is k sub t. All of that represents k sub t, which is what we had to substitute way up here. Uh-oh, you can't see it. Way up here. Our solution is x sub t is equal to k sub t times that. We now know what k sub t is. So we have x sub t. I'm just rewriting what I had up here. X sub t is equal to k sub t times e to the negative 3t. We now know what k sub t is. We just figured that out. So we end up with 1/3 t e to the 3t minus 1/9 e to the 3t plus c. That's k sub t, and we need to multiply that by e to the negative 3t. All right, so we end up with x sub t. Uh-oh, you can't see it. Sorry. X sub t is equal to, let's multiply now. We end up with 1/3 t. You're multiplying e's. The bases are the same. You add the exponents. It's e to the 0, which is 1, minus 1/9. 1/9. Again, e to the negative 3t times e to the 3t. You add the exponents when the bases are the same. We get e to the 0, which is 1, plus c, e to the negative 3t power. Final answer. And thank God, we end up with 1/3 t minus 1/9 c e to the negative 3t. We got the same answer. All right.